Okay, mes amis, as I told you, I will show you the source of the Baalbek giant stones. Only I have the same ones here, only they're quite a bit smaller. Let's dig into details. All right, I'm going to show you something about abrupt transitions and little short tendon pieces. That's a little short tendon piece. That is literally what does this on a finger. This is the piece that comes right down on the side of every finger, so you can go this way or that way. This is the muscle that wrapped around the bone ball, which this side has eroded all the way down to the actual ball. This is red, fleshy tissue that was the muscle. This is the flat tendon right here. This is the flat tendon. It died laying like this. This is the abrupt transition. Now, remember I talked about pinchy bundles? There's a pinchy bundle right there. I'm going to have to get better lighting and so forth for you to see it perfectly, but that's where they break an abrupt transition. From there, it turns into the muscle, which lets your finger do this. So that's really this tendon right here, and it breaks right about there. Now, it should be fully understood that I work under the Fair Use Act, which means that I can use copyrighted material from anyone without their permission, as long as it's for a transformative commentary. It's exactly what I do. This is as transformative as it gets. If this is a tendon fiber, and these are the little blood vessels, and these are the colors of the synovial sheath, the blood red and black, which I've shown 1,000 times, and these are the size of these fibers, and these are the number of people can sit on one tendon fiber. Just think about that. All right, so I'm not using anybody's copyrighted material for any other reason other than transformative, educational understanding of our reality. Okay, my friends, another shocker. Everybody knows what the Baalbek stones look like, I assume. They're big, square, huge 1,200-ton blocks. They're flat as a pancake on one end, just flat like this, separated on both sides, made of this kind of material. This is tendon. It's from a specimen I have here in my shop. I have it right down on my microscope right now. We're going to be looking at it a little closer. Tendon attaches to muscle. Well, how does it do that? It glues. I mean, it literally glues. Flat as a pancake. You see this one stepped off here? This one stepped off here. They're all separate fibers, and they can move back and forth in this glue. And that glue attaches to this muscle. Okay, I'm going to move the microscope forward. Just keep an eye on this. Don't forget, these are the Baalbek stones. That's the glue that glues the tendons to the muscle. The muscle weaves in to that glue. Alright, so now we're going to move the microscope down a little bit. You see this, the red and the black? This is all the blood. You see that, how flat that pancake, that abrupt transition is? Okay, now, hold on, let me stop this. You see that? That's a muscle. It literally wraps in, just like a little strap wraps in. And this stuff here, the white sort of stuff, that's connective tissue. This is the muscle, the black, well, it looks black, but it's red. Now, let's go a little further. As we come out, you'll see that you'll start to get more and more red, but we still have a hell of a lot of connective tissue. And you're going to see some abrupt, whoops, hold on. All right, something happened, I don't know what, but here we are back again. Now, whoops. Pay attention real close here, because this is important for you to understand exactly what's going on. Coming up to here are fibers. They abruptly end right at the glue. I mean, as abrupt as you can be, just as flat as a pancake. And inside, underneath, in the middle of these, is some nourishment, because everything needs to have some nourishment to it. And you'll see that in the pregnant lady stone. And you're going to see the colors, the red and the black, and all of these different synovial sheath running all over it. Now, I'm going to go a little further here, and we are going to see the muscle weave into the glue. This strip here is the glue. Tendon, glue, muscle. Muscle goes out, attaches to bone somewhere to another tendon end. But this stuff here, this is the gnarly stuff that's on the top of Fingal's Cave. Fingal's Cave is like this, sticking straight up. All right, and this is the gnarly stuff on top. Fingal's Cave is like this. All right, the water is here. Fingal's Cave, the shoulder is right here. And then all these abrupt transitions come up to these little fibers that I just showed you. And there's huge gaps in here because this is the hip bone, and it dissolved. And there's a cradle up there. And that was the glue on the top of Fingal's Cave. I did a good video on it yesterday, I believe, the day before. And it showed this exact structure. And I'm going to do another one today that will show it in extreme detail. This lady did a very, very nice job. And I will show you her channel in a minute. But this is where we are here, into the abrupt transition glue. And then into the muscle. It's a different area in the body than that hip, but it's very same. The glue is the same. Now you come into these little straps that run down and catch into that glue. You see them? The bundles right here. I probably showed you this already. I get lost in these presentations. I got so many things going on. But as it comes out, all of the white stuff is connective tissue. And some of it is really heavy-duty connective tissues, very mineralized. But in between this reddish stuff coming out is the bloody muscle fibers, muscle tissue. And that's the stuff that erodes. And you see, when you see things are heavily eroded, you see these layers in between. These are the connective tissues. They don't erode like the other. You see that right there? You see this? This is an abrupt transition. It's going from heavy mineralization into more muscle. And that just keeps, and there's 3 or 4 of them, because there's another one right out here that's already broken. All right, that's what I'm saying. What I just showed you in the microscope is one of these fibers. These are people sitting on there. These are the colors of the blood running out from the synovial sheath. All right, these are what they build the temples out of. You see these stones? They say, where'd they get those from? Well, that's where they came from. They had to have giants, huge, gigantic people still here to do this work. And this was done after the flood happened, because that's what made all these body parts pliable, really. So they could carve them up easily, and they created Petra and all that stuff. Okay, I've shown over and over the size of the creatures that were here on Earth were just astronomically large. That right there is a single tendon fiber. It's from a specimen I have here in my shop. We're going to be looking at it in a microscope, and I'm going to go through all the different layers, because the sand, into the mud, into the tendon, into the limestone. This is a tendon fiber. You see how it steps off from one to the other? They are individual fibers. This right here is an absolute flat, abrupt transition, as flat as it can be. And if you look at the pregnant lady stone, that's what it is right there. And at the very end, it's flat as a pancake and has some little red bloody stuff at the very end, little holes in it, that come and glue into this glue. Now, we're going to get a little deeper in here in a minute, but this is, I know it sounds insane, but that is where the Baalbek stone came from, one of the biggest stones on Earth, the pregnant lady stone. And that's from this specimen right here, coming from the side, looking at the tendons. Right now we're looking at the top, because like I say, I want to show you all the different layers. And that is right there, the surface layer, which it turns into sand. That's why we have so much sand. I'm not kidding you. It's just that unbelievably true. And then I've shown the interstitium, which gives us those round balls that are all over the Earth. Some of them are gigantic. I've shown you all the I've shown all that stuff over and over and over. My stuff is DNA tested, and every single scientific, everything I did was scientific. Now this video that I'm showing you right here, this is from 2015. I couldn't get anybody to look at it. I still can't. And that's what the pregnant lady stone was. Now I'm going to show you how this glues into muscle, and it is also the same fibers that make up what is that place? Fingal's Cave. And it's the same fibers that are in Devil's Tower and all of them. All of these big structures that have these hexagonal and so forth. Some of them are flat like a pancake, square. That's a different type of tendon. Then there's other ones that are hexagonal, and they all flow from one another in different parts of the body. This is from this specimen that I have right here, and I think this is a hip or a shoulder joint right here, because I'll show this in great detail. I can show you where the bone ball was, where the original tendon straps came, where they glued in there, then where the muscle started. We'll see it all in a second. Okay, it's over the top, no question, but this appears to be the shoulder or the hip or something, but it attaches between bonish material up to an anchor that anchored a ball, some type of a ball that was here. You could see this. You could see the shape of it. It was sat right there in that cradle, and it glued to there. But calcium didn't make it in the Great Flood. Calcium was just dissolved. That's why it's gone. But not this stuff. Not this stuff. Okay, this is a really good video showing a lot of detail. This is Monira's vlog, UK. Monira's, I'm not sure exactly how to pronounce it. She did a great job, and I appreciate being able to show this for informative, transformative, educational purposes. That's a body part, and it cradled a bone ball that eroded away. Bones did not make it. Salt and water and bones did not work out well. I got a bunch of bones here that I did in salty waters and different types of chemistry and so forth, and it just doesn't hold up. It just doesn't stand up. I just grabbed one here, a second ago. You see this one here? I just picked it up and it just fell apart. I'll look at these in a microscope and you'll see what happens to, chemistry is very, you have to understand chemistry. Everything's different. Bones are different than mud. It's different than limestone. It's different than, blood. And I mean, everything has a different chemistry to it. And if you don't understand the chemistry, of the pHs, salts and acids and how they work each other and they beat each other up using these transition metals in aqueous solutions. They're called transition metal complexes. And they carry different molecules back and forth, and it's called invading groups and leaving groups, and that's all it is. The stuff comes through there, and it's called, a lot of it is carboxylation, carbon. That's why they don't understand it. They can't do carbon dating. It doesn't work. If there was ever any moisture in there, carboxylation changes the carbon that was in there. All right, they really have to do some more work here and start to understand transition metal and carbon bonds and how in aqueous solutions they move. The carbon moves. So don't tell me this carbon's, you can date anything by using that method. It does not work at all. Now, let's go a little deeper. All right, I'm going to show you something about abrupt transitions and little short tendon pieces. That's a little short tendon piece. That is literally what does this on a finger. This is the piece that comes right down on the side of every finger, so you can go this way or that way. This is the muscle that wrapped around the bone ball, which this side has eroded all the way down to the actual ball. This is red fleshy tissue that was the muscle. This is the flat tendon right here. This is a flat tendon. It died laying like this. This is the abrupt transition. Now, remember I talked about pinchy bundles? Here's a pinchy bundle right there. I'm going to have to get better lighting and so forth for you to see it perfectly, but that's where they break an abrupt transition. From there, it turns into the muscle, which lets your finger do this. So that's really this tendon right here, and it breaks right about there. Now, I showed them in other areas, too, from that other shoulder. This is a finger. Does that look anything like what you're seeing right there? These little pinchy bundles? You see them up there? You see the one we were looking at here? They're both from tendon emplacements. And that just happens to be uncommon 67P, and these just happen to be identical to the tendon fibers I showed you. And the gases coming off of 67P are identical to blood gases. And the gases that come off in the solar winds and are out in outer space are identical to blood. All right, do I have to get any more explicit than that? As far as I can determine, there is nothing that is not biological. All right, everybody thinks it's just dust goes blowing off of these comets when they go flying through, and that's why they have these tails. Well, they have the tail because, yes, they're spewing stuff out, but it's not just blowing off of there. You see what's happened here? This is the direct impact of the sunlight into a giant blood vessel, which spits out literally cooking gases like out of your gas grill. These are little bitty ones, because everything has to be serviced with blood, but these are blood vessels, and the light is hitting it into the blood vessels. It's hitting here. You don't see any smoke coming off of here. There's no blood here. That's the outer, that's the coating around there. That's the fascia. No real blood in the blood vessels. These have blood coming out. I mean, they're shooting out of every single blood vessel, every single one, out here, out here, out here, out here, everywhere. And then, of course, the thing just keeps going by, and that stuff trails behind. But it has nothing to do with dust blowing off, nothing whatsoever. And these particles are, and they sampled them. This was from a Philae lander, European Space Agency, February 2015. I followed this from the day it started to the day they just threw their hands up in the air and walked away from it. Because they said it's all organic. And an anatomist, anybody with half a freaking brain can see what it is. So they just walk away from these things. See that once again, all blood vessels shooting out all over the place. That appears to be either a heavy-duty blood vessel or some form of emplacement. I don't know what. All right, this just shows you everything's shooting out of blood vessels. This, I'm not sure what that is. It could be a heavy-duty blood supply, or it could be a tendon, or I'm not sure what. All right, you see these places, these don't shoot off any gases because they're not blood supplies. This is where your blood supplies are, all going to the really active tissue. This is an anchor, so they don't burn any gases off of there. You see this? That, they call these dragon balls. You know what those are? Those are little tiny blood vessels. Everything has to be serviced with blood. There's cells everywhere. So you have to have that much intrusion of blood. And this is the one that blows out like crazy. You see this? 40 meters is this long. So you got 40, 80, 120, 160 meters across there. In feet, that's what, 450 feet. 450 feet for one artery. You see, that's the artery. That's that sucker that's just shooting meat smoke into space everywhere. These are just little ones servicing everywhere else. But this one brings the blood down, the full supply of blood down. All right, they're all body parts. I've looked at all of them, and they're body parts, as far as I can tell, every one of them. This is a finger. This is Comet Amaru Maru. I've shown this to anatomists. Nobody disagrees. They say this is exactly what a finger looks like. This is what they call the apical tuft. And this is one that's from a mud fossil. And what it is it's a tip on the tip of your finger that has a ton of little ball holes in it. And all of the straps come up and they lock in. This is a big flat tendon. The rest of it runs all the way down to here. All right, take your time. All of these little balls run into a circular patch of holes that are on the bones. If you see a bone, it runs down, then you see a whole bunch of little tiny holes down the end, and people don't understand. Those are where everything locks in. I'll show you some anatomical in a minute. And then, of course, the apical tuft is up here. They have to anchor in two places so you can do this kind of stuff. Now, this is grip skin. You can actually see the fingerprints if you look really close, I think. Now, this is where you're twisting here, right here. First of all, right about here is where your first tip is, where your first bend is. This is the center of your finger, the knuckle, right there, or whatever you want to call it. Now, running down here is more of this tendinous material, and it locks in down at the base of your finger. And one side is the black, and one side is the red, which is the artery, vein and the artery. And it runs up and it runs back. Now, if you look at this carefully, if you take this to an anatomist, you see right there? That's right there on the top of the bone. It ripped off. The bone would have been right in there. And this sticks straight out, just like this finger. The bone ball would be right here. Right, and that makes everything go off of that knuckle like this. So that's one it's pretty obvious what that is. And again, not a single anatomist can argue with that. If they do, I would like to ask them what is missing there. What are we not showing? If that was a finger. Now, and they say, well, how would a finger get in space? Well, all I can tell you is there was, in ancient texts, there was battles in the heavens. And I've shown there's creatures that are just astronomically large. No accounting for that other than the ancient texts talk about this. This is not a mystery if you read the ancient texts with a critically open mind and say, is there any evidence to support it? And yes, there's evidence everywhere. Everywhere. And I mean literally everywhere. So again, people that want to walk around in circles, I don't think that's the way to live your life, but it's certainly not the way to profess to other people that they have to say those same things or be counted as irrelevant and incompetent because they can't repeat what they're told to say, even though it's wrong. And they know it's wrong now. I can't believe anybody of any ability would stand up and say that I'm wrong about the things I've been saying. And if they have an ability and they would like to confront me, that's what I've been demanding, and but nobody will respond, none. I don't blame them, because they want to keep their status and just avoid truth. You can't avoid it forever. It cannot continue like this. It's absolutely insanity. Okay, one thing I get from a lot of people, they say, oh, that's just an artist's drawing. Well, yes and no. How they get this absolutely flawless imagery is by taking a whole batch of pictures from a whole bunch of different sun angles. So what they end up getting is, like you see this abrupt transition, this is the white connective tissue coming down to wrap into those little balls, those little holes that I talk about. And the reason they can see them in such fine detail is because they got an angle, and they can see the shadows that they make. And that's why they can see where the tissue broke off. And they can see, and then of course they can see different intensities of light and darkness. And tendons are always white. I show you they're always whiter than the surrounding tissue that is the muscle and so forth, and certainly the red blood and everything. And this is the grip skin. It peels right off. Exactly what happens in my stuff. There's no difference whatsoever. So an Avi Loeb from Harvard testified before Congress or something that this might be a spaceship. Well, I can't say it's not a spaceship, but I can tell you what, it's a finger. They might be using it as a spaceship now. I have no idea. These things are gigantic, and they're out in outer space, and they're all from biology as far as I can determine. So do I have anything from outer space that might be biology? Well, guess what? I think I do. That's a little iron meteorite, just a tiny one. All right. Now, can I show that that's from a living body part? Yes, I can. Can I prove that? I believe I can. And how will I prove it? If it has the body part that's just been identified called the spurlock. Because I say this is a lung. If it has a spurlock on it, I'm in good shape. Let's see if it does.